Hey, Austin here again, and today I'm going to show you guys how to install a turbo Sunbird tachometer in the Fiero, and I'm also going to show how to take apart the Fiero instrument cluster in order to get it in and what modifications you need to make to put it in there. You might be interested in putting this gauge in because it's not an aftermarket sloppy looking gauge, and if you were running a supercharger or boost, this particular gauge is similar to the Pontiac Fiero style tachometer, but it has a integrated boost gauge in it. You can actually print out a faceplate and lacquer it on the front. I'll give the link to that. There are those drawings in the description. Somebody was nice enough to make up a good looking one. I don't think I'm going to do that because this is actually from an 86 Turbo GT Sunbird, and it happens to look very similar to the Fiero, same font. The font is bold and the lines aren't quite the same, but I don't want to mess up the face of the gauge, so I think I'm just going to put it in as is, and it's going to look quite stock. I think that GM Typhoons and Cyclones also had the same boost gauge. They're from the mid-80s, like 85 through 88 or 9 maybe. They're all a little bit different style. I think this 86 one looks the most similar to the Fiero, so I got an 86 one. I got it from carpart.com. I'll include a link in the description of that too. So, quick lesson learned, don't take the needles off, just leave them. I ended up spending about 3 weeks making this video. I ended up having to hack together my old Fiero tachometer spring that is on the analog motor coil, and actually it worked pretty well, but I just wouldn't bother with it. It took me so long to figure that out. In addition, do not what's actually screwed me up is I bent the spring. Do not twist or spin the needle a couple of times over. That will bend the spring out of shape, and you will change your spring constant, and then you'll not be able to calibrate at all. So you're going to start by taking the 4 screws out in the dash. I used a T15 Torx bit to get them out. You can adjust the steering wheel here if you have the tilt wheel to get your screwdriver in other ways. I think that there is a cover missing from my Fiero, but you'll have to take a cover off. It's either probably a 10mm or 7mm bolts to get off. Up above the gauge panel, there are 5 screws. There's 2 hiding behind here. They're all T15. Take those off and then pop this cover off. There is also 2 7mm bolts on either side that go through here. Mine was missing right here. They're on either side, so take those out too. And there are 2 additional bolts, both 10mm, behind the steering column. So now it should be loose, and we're gonna have to unhook all of the wiring harnesses back here. So go ahead and do all those. This instrument cluster is loose. You can kind of pry out the actual cluster from the housing, and I need to take out, I think, 2 connectors to it. This black one and then a white one over there. And there's also a 3rd connector underneath the bottom. And there's 5.5mm bolts on the face of this. So that plastic cover comes off, and then the faceplate comes off too. There are 2 more 5.5s holding the tack in. So slide the old tack out. There we go. That'll be a great time to change some bulbs. I got the Rodney Dickman bulb kit. What are these? 2825 bulbs. They're supposed to be a little brighter from RodneyDickman.com. Speedometer just comes right out, and so do these guys. And you can change the bulbs there. Rodney Dickman only comes with the backlight bulbs, actually, not the shift bulbs or the warning light bulbs. Before putting new bulbs in, I would always test the new ones that you got. Here we go. Because you don't want to put it back in and then have half your bulbs out. A little variable power supply. It can put out 5 volts, 12 volts, whatever you want. You can also try it with like a 9-volt battery maybe. Plugged in, I would additionally jump across each bulb with your voltage, like so. See if it comes on or not. That way you can tell if the socket needs some adjusting or the pins on the bulb needs adjusting. While you're at it, you might want to take this off to change lights too. It just takes 4 T4 torque screws, or sorry, T15 torque screws around the outside, and then 2 Phillips screws for the faceplate. And this guy should pop out and give us relatively easy access to the light bulbs in there. One there and one there. So I just noticed in the car when I plugged it back in, I left trace lifted, and this light bulb is not working. You might have noticed that, not on. Basically all I did is follow the traces and I applied voltage to that 3rd pin from the bottom, or from the top there, and then actually is this light not working, and then I was able to isolate the trace to right here. Take this light bulb out, it just kind of unscrews. My trace lifted a little bit right there, and that light bulb no longer has a ground connection, I believe. So I'm going to solder that back. Just be careful with this thing. Don't bang it around too much. It's old and delicate, brittle. And there's my solder glove. It works again. Fit perfectly. We're going to have to trim a few things to make it fit. I'm going to start by trimming this corner off right here. There's no vital circuitry around it. We're just going to cut it at a 45-degree angle. And you're going to want to grind this down. Quite a bit of a notch there, maybe about a 1/2 inch by a 1/4 inch down, and then maybe take a 1/4 inch off this guy. I use a Dremel. I'd run it at a high speed so that it doesn't throw shrapnel everywhere, instead it melts it together. So cut those down until you have about 3/16 of a of this thing offset from the face here, from the top surface there. And then we're going to cut a little notch in this screw post where that circuit board is, so that the circuit board can slide into it. So I'm going to mark right there and cut. So that notch is cut. She's sitting in there pretty snug. Try the cover on to see that it is centered. That looks pretty dang good. You also need to cut this little piece of this little corner off so you can keep the area here round. So on this piece that we cut out a notch in, put some flexible electrical tape over that hole so we don't bleed the lights into there. 3 pins you'll be using are this one for 12 volts, this one for ground, and this one for tachometer, as well as the green wire that comes off for the boost gauge. Now, the boost gauge is actually controlled by a 0 to 5 volt signal. 2.5 volts should mean that it is at 0 boost. Find some nuts that fit these. They might be 632 nuts. And I'm going to cut all of these posts down by probably 2 millimeters or so. After you make the cut, make sure the nut is on before you do it. You're going to unscrew the bolt to reshape the threads, or the nut to reshape the threads on it, so you can screw something else down later. Try to put a 1/4 inch drive on this end of the screw here, to keep the torsion off of the trace. I get about 3 strips of 18 gauge wire, about maybe 6 inches long or so. Strip both ends, and I am crimping with some wire strippers, some ring terminals on the end to screw to my the contacts in the back. Then my ring terminals are small enough I can fit them in to this contact on this side with a screw. I use a 632 again. Pull these contacts apart and then squeeze them back together, because we're going to use them again for calibrating later. Careful when you do that. I snapped one of my contacts off. It doesn't matter because I'm not going to use it on the new one, but it would help to keep them to calibrate the new one to the old one. Once the screws are in, I would cut them down quite a bit so that they don't interfere. So this is 12 volts here,
On the right, it goes to this pin on the far upper corner. Make sure you get this oriented correctly. Don't look at it backwards. This pin here is the tachometer coil that goes to this one, and this last pin down here is ground that goes here. Here's one potentiometer for a trimmer. It's 1 mega ohm, and you only need to solder the middle and the outside pin to either of the connections that I'll show you. Here are the pins that you need to solder to. This is an 86. The other ones look a little different. You can find links to them in my description again for different styles. You actually have to cut this pin, and just keep in mind these letters are upright, right? You've got to cut the fourth one up. 1, 2, 3, 4. Fourth one up on this side. That trace right there going to the other chip. Cut that, and then solder from this point to that point, which is the third one up on the right side of this chip. I would start by tinning the wires, meaning heat up the wire and feed some solder into the braided wire, so it takes a little bit. I put a washer and a screw back in to kind of hold this down. It's actually in there pretty tight. So go ahead and plug her in. This is why we need to install that potentiometer and calibrate it. I'll show you here, I'm actually running 960 RPMs, but it's showing up as 2000. So we're going to put that potentiometer in and adjust it. I'm using an app on the iPhone called OBD Doctor on the iPhone, and I bought this little V-Peak thing. If you don't have a OBD2 connector on your engines, like a non-3800 engine, don't calibrate this way. Make sure you keep your pins. Then what you're going to do instead of calibrating the way that I'm calibrating is you're going to hook up the other speedometer in parallel and make sure that that the old one is the same as the new one, and then adjust your screw. I'm going to adjust mine with this guy though. You cannot do this if you switched your needles and you don't have one of these guys. Yeah, you cannot do this if you switch your needles, because when you take your needle off, you're going to put it on the wrong spot.
So quick lesson learned, don't take the needles off, just leave them. I ended up spending about 3 weeks making this video. I ended up having to hack together my old Fierro tachometer spring that is on the analog motor coil, and actually worked pretty well, but I just wouldn't bother with it. It took me so long to figure that out. In addition, do not, what's actually screwed me up is I bent the spring. Do not twist or spin the needle a couple of times over. That will bend the spring out of shape, and you will change your spring constant, and then you'll not be able to calibrate at all.
Turn this screw until, or the potentiometer until you hit the exact right amount of RPMs. And you can plug your gauge in parallel, your stock tachometer in parallel. I couldn't because I switched the needles, so both of them are off. Do not switch the needles. I do not recommend this. It is very hard to get the needle in the right position. The way that I did it was that when it is off, I pull the needle off and make sure that the arrow is pointed towards, the ignition is on, the arrow needs to be pointed exactly towards 0. When it is off, it should be pegged. On towards 0, off, pegged. Very hard to get that needle in the right position. But then once it is, just use the potentiometer to adjust it. So bolt everything back together. Pretty straightforward. Just watch this video in reverse. And be sure to test that before you tie it all up. Then what I did is I left a little bit of green wire. I don't know if you can see that there. I left a little bit of green wire sticking out, and I wire butted it to another green wire. Ran it, fished it along through here. Just kind of shoved it up under the trim, so now it's coming out right here. And what I did was, since I have a 3800, this is my old 2.8 connector to the ECU. What I did is I took the green pin off of that and I stripped it. Now I'm going to connect these two. And with a multimeter, I was able to do a short check on the harness itself and find that wire, which is no longer being used, sticking out right here at the end on the engine side. This wire I'm going to wire butt to the ECU or the map sensor directly. So my MAF is right there, and I actually teed off of the MAF signal. It's a middle green wire using a butt connector. You could also alternatively tee off of the signal close to the computer, which is, I believe, pin 25, at least on mine. Mine is a Bonneville computer. I'll let you know what pin here right below, and let's test it. You can actually calibrate the boost gauge by screwing that little potentiometer right there. But like I said, zero should be at 2.5 volts. So odds are the boost gauge is already calibrated, but we know, I'll show you a chart here, that when the map sensor outputs 2.45 volts, you should be at exactly zero boost. If you manage to pull it off, I've got a power supply reading 2.5 volts. On the multimeter, well, it read 2.45 volts. If you can manage to get a 12 volt supply in conjunction with the 2.5 volts or 2.45 volts, ground them together and apply ignition voltage, ground, and the 2.5 volt signal to this pin, ignition voltage and ground their appropriate pins, and make sure that the gauge reads zero. So I can see that I have 2.45 approximately volts across the gauge here, and I'm reading a little bit above zero, so I'm going to adjust the potentiometer that is soldered onto the circuit board until it gets down to zero. Potentiometer with a little mini screwdriver down there, and you see I already got it. Nice. Nice. So make sure all your lights still work, blinkers, your brights, and your door jar, etc. Thanks for watching, guys. Remember to like, share, subscribe, and comment. I'll answer any questions you've got, and good luck.